Hi, I'm John Gamble. I'm an applications manager for Silicon Labs. I'm here to talk to you today about I2C and SMBus isolation using our industry-leading Si8400, Si8401, and Si8405 bi-directional isolators. I2C and SMBus are similar. Standards details can be found at NXP UM 102-104, I2C bus specification and user's manual, June 2007, or smbus.org, System Management Bus Specification, August 2000. The interface is a two-wire bus that can have multiple masters and slaves on the same bus. SCL is the clock line and SDA is the data line. Both SCL and SDA can be from host to slave or slave to host. SCL and SDA are driven by open collector drivers. A device pulls low to send clock or data. The protocol includes bus arbitration in case several devices pull low at the same time. The principles I will be discussing apply to any I2C or SMBus application where isolation is desired, such as power sequencing controllers, real-time clocks, temperature sensors, or other smart sensors. In the Power over Ethernet application, the Power over Ethernet controllers are isolated primarily to eliminate a possible ground loop between the power sourcing equipment and the powered devices. Isolation is also required by the IEEE standard for Power over Ethernet. This is a block diagram of a Power over Ethernet power sourcing equipment system showing the placement of the isolators. The Si8400 bidirectional isolator is used if only the I2C wires SCL and SDA are used. The Si8401 can be used if only one device drives SCL, which is not the case for the Si8452. The Si8405 adds optional single directional channels for the reset and interrupt signals. I chose the Si8405 for this reason. You can see that the isolator has an A side and a B side, and I have chosen the A side to face the Si8452 devices. I will explain this in more detail in the next slides. Here's a top-level diagram of a bidirectional isolator connected between two I2C devices. Note that the isolators are connected in opposing directions, creating a latch condition when an isolator output logic low propagates back to an adjacent isolator channel. This problem is eliminated by adding special anti-latch circuitry to the A side. The A side output low, VOL, and input low, VIL, levels are designed such that the isolator VOL is greater than the isolator VIL to prevent the latch condition. The reason I chose the A side facing the Si8452 is that the VIL level of the Si8452 is compatible with the special VOL level of the Si8405. Let's look at a few waveforms on the Si8452 MS8 evaluation board to understand this in more detail. Here is the Si8452 MS8 board. You can see the Si8405 isolator U101, two Si8452 PoE controllers U1 and U2, and an Si3500 DC to DC converter U152 to generate 3.3 volts on the isolated side. The isolation barrier is easily seen. For demonstration purposes, we will use a USB to I2C conversion board that uses the Silicon Labs USB microcontroller. The power for the isolator on the system side comes from the USB power. I've already attached some test points. Now we are ready to look at some waveforms. Here are the SDA waveforms on each side of the isolator. The blue traces the A side and the yellow traces the B side. When the isolator is pulling down on the A side, it pulls to VOL. The Si3452 pulls down on the SDA during the acknowledged portion of the I2C waveform. When the Si3452 is pulling down on the A side, it pulls to a voltage slightly higher than ground. The isolator VIL is centered between the isolator VOL and the Si3452 VOL. This allows the anti-latch circuitry to work. Now let's look in more detail at a low to high transition when the Si3452 stops pulling low on the A side. In this screenshot, blue is again the A side and yellow is the B side. The initial low on the A side causes a low on the B side. When the A side releases, The B side must go high before the bus can release on the A side. This demonstrates the Si8405 anti-latch circuit in action. Relative to typical I2C clock frequency of 400 kilohertz, the approximate 30 nanosecond delay in the B side transition and added 30 nanosecond delay until this propagates back to the A side is very acceptable. I hope you have learned about how bidirectional isolators work and how they can be used to provide isolation of an I2C or SMBus in typical applications such as Power over Ethernet. Silicon Labs offers several tools to assist you in evaluation of the Si8400, Si8401, and Si8405 bidirectional isolators. Please visit us at www.silabs.com/isolators. Applications Note 375 covers the detailed design considerations for the A side. The Si8452 MSA kit is available, particularly for those with an interest in Power over Ethernet. The Si840X I2C evaluation board is available for evaluation in other applications. Thanks for watching.